Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an exponential equation, a rationally exponential equation with complex numbers. So z is an unknown, z is a complex number. What is a complex number? Well, if you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, go ahead and check out my other channel, my main channel, or my first channel, the very first channel, Cyber Math, Cyber with an S. And if you have any questions, always ask. That's how we learn. So, to be able to solve this problem, couldn't we just distribute the exponent? I mean, we can write it like this, 2i to the z and 1 plus I to the z equals this. Z is the unknown, so that kind of makes it a little harder. So we're going to use what is called complex exponentiation. In other words, if you have two complex numbers, w and z, and you have to exponentiate them like this, w to the power z, what is a complex number to a complex power? This is what it is. We can use the exponential function to express that as e to the power z ln w. But then the question is, what is the logarithm, natural log of a complex number? That's called complex logarithm, and it's multi-valued. So we have to be careful because in the Argand plane, you can make rotations. And it'll bring you to the same point if you add 2 pi or multiples of 2 pi. All right? So here's what we're going to do then. Take that equation. First, 2i to the power z. We're going to write it as e to the power z ln 2i. And 1 plus I to the power z, we're going to write it as e to the power z times ln 1 plus I. And then we have to find the logarithms, right? But first, let's divide these things. When we do, it's going to be like e to the power z ln 2i minus z ln 1 plus I, because when we divide, they have the same base. We are supposed to subtract the exponents, right? Exponentiation rules. That equals this. And then let's go ahead and find out what ln 2i is. That will be by definition ln 2 plus I times pi over 2. But pi over 2 is not the only angle. Like I said earlier, we can add multiples of 2 pi. N is an integer. I said that, I didn't write it, so hopefully you remember. ln 1 plus I, on the other hand, is very similar. Its modulus is root 2. So we're going to ln that first, and then I times the argument. That's how you do the complex logarithm, but of course write this in general form. And then later on you can go into the specifics, which we'll do. Okay? So those are the logarithms. I'm not really going into the details, but if you really wanted to know the details, ln of a complex number, let's see, should I use w? Yeah, I think w is more meaningful. ln absolute value of w plus I times the argument of w. An argument is a general one, which includes multiples of 2 pi. If you wanted to write the principal argument, then you will use uppercase A most of the time. And I believe this is also going to be an uppercase ln. And I don't know if it's standard, but I think that's what it looks like. So this is what we have so far. Now let's go ahead and use this expression. I mean, we used it, but let's go ahead and plug those in. Okay? So here's what we're going to have after natural logging both sides. We're going to get z times ln 2i minus ln 1 plus I equals ln 2 root 2 plus. Now, how am I going to write this in polar form? Its modulus is 2 root 2. If you graph it or plot it, I can show you. This is what it looks like, negative 2 plus 2i. So it looks like this. And the angle it makes is actually 3 pi over 4 radians, because pi over 2 plus pi over 4, or you can kind of look at it this way. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. You see, those are all multiples of pi over 4. That's how I remember usually what those angles are. So this is I times the argument is 3 pi over 4. Okay? That's the formula for the log of a complex number, or the complex logarithm. Of course, you're going to divide both sides by this, but what is that? We already talked about it. What is this? We already talked about it. Plug it in and find the answer. What are you going to get? Let's find out. ln 2 root 2 plus I times 3 pi over 4. By the way, I just used the principal argument, but if I want, I can write this in more general form, like plus 2 plus pi something. You get the idea? Now let's go ahead and replace these with what they are. ln 2I, what was that equal to? ln 2, okay, plus I times pi over 2 plus 2 pi n. And then from that, I need to subtract ln 1 plus I, which is going to be ln root 2. And of course, I have to subtract like this so that it can be negated, pi over 4 plus 2 pi k. Because for the second number, 1 plus I, the argument is pi over 4, but that's just the principal argument. Make sense? So, good luck with simplifying this. This is the answer. This is the solution. But there's actually a nicer way to approach this problem. Just a bit, like a tad bit nicer. Well, let's go ahead and take a look. You decide which one is nicer. Second method. So we have this expression, right? So the idea is, why not simplify the base? We can do that, right? So let's go ahead and focus on 2i plus 1 plus I. You know why? There's a good reason. I'll show you. First, we multiply by conjugates. This becomes 2i times 1 minus I. This becomes 2 from sum of two squares. And then 2's cancel out, distribute I minus I squared. But I squared is negative 1. Don't ever forget that. This becomes 1 plus I. Uh-oh, I divide this number by 1 plus I and I get 1 plus I. What is that supposed to mean? Well, you should know that 2i is 1 plus I squared. If you knew that, ta-da, we can just go with this, right? Easy. So now we have 1 plus I at the base, which is super duper nice. And then I have that equation. Much nicer, right? It looks much better, I think. I could be wrong. But anyways, you can try, like, raise 1 plus I to any power. But let me tell you something that is going to help. Maybe I should show you the method and then tell you about it if I don't forget. If I do, I apologize. So we're going to go ahead and write this as e to the power z ln 1 plus I. And this one, you already know that, right? 2 root 2 times e to the power I times 3 pi over 4. But again, we can just write 2 pi m. We can add multiples of 2 pi all the time. And for the ln 1 plus I, I'm going to do the same thing. E to the power z times ln 1 plus I is just going to be ln root 2 plus I times pi over 2 plus 2 pi. Let's just use another variable t. T is an integer, by the way, as well as m. And then this will become this, okay? I don't want to write it again. Now let's go to natural log both sides. That's going to give us this, which is z times ln root 2 plus I times pi over 2 plus 2 pi t equals ln 2 root 2 plus I times 3 pi over 4 plus directly from here 2 pi m. Awesome. Now let's go ahead and isolate z. That's going to be ln 2 root 2. I'm not using parentheses. I hope that's understandable. I times 3 pi over 4 plus 2 pi m. Remember, m is an integer. Divided by ln root 2 plus I times pi over 2 plus 2 pi t. Okay? And by the way, this shouldn't be an pi over 2. That should be a pi over 4. I don't know why I wrote pi over 2. Let me fix that real quick. Oops. I should probably use a partial eraser. Let's change that to a partial. Okay, cool. Now we're going to go ahead and make this pi over 4. And make this pi over 4. And what else? And this one too. Okay. And that's pi over 4. Now, that's the answer, right? Do you like that? Well, it kind of looks complicated. We're also going to check Wolfram alpha. But here's what we can do. If m and t are both 0, which is going to give you the principal values, we're going to get something like this. ln 2 root 2 plus I times 3 pi over 4 divided by ln root 2 plus I times pi over 4. Now, if you look at this very carefully, you're probably going to realize that 2 root 2 is root 2 cubed. So I can write this as 3 ln root 2, because that's cubed, plus I times 3 pi over 4 divided by ln root 2 plus I times pi over 4. And then finally, factor out a 3 ln root 2 plus I times pi over 4 divided by ln root 2 plus I times pi over 4. Uh-oh. Houston, we have a solution. Z equals 3. Now, z equals 3 is obviously a special solution. But why does that work? Because if you take 1 plus I and cube it, you get negative 2 plus 2i. And of course, that makes sense. But 3 is not the only solution. This is the general solution. Make sense? Let's go ahead and check Wolfram alpha. And that will be tada. Unfortunately, Wolfram alpha did not simplify. By the way, what Wolfram alpha calls log is natural log. Unfortunately, that's how it calls it. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.